Well, have you ever heard this little riddle? Somebody will ask you, which is heavier, a pound of feathers or a pound of bricks? And people answer that wrong all the time because you imagine holding feathers and bricks and you say, well, obviously bricks are heavier than feathers. But if you listen carefully to the question, it said a pound of each one. And so the answer, in case anyone asks you, is they are the same. Neither one is heavier than the other. Now, a pound is a pound no matter what it is. What is it that people mix up? I claim what they're probably thinking of is what we refer to as the density of brick or the density of feathers. Because it's definitely true that bricks have a higher density than feathers. So let's talk about what that density is and why that question fools people all the time. So let me give you kind of the sciencey definition. Density is the amount of mass which I understand mass is still kind of an unfamiliar concept to you because in the United States, we don't often measure the mass of things. They do that in other places. So we've measured mass on the balance, okay? And so we measure it in grams or big things like kilograms. But we're used to measuring weight, which is actually the effect of gravity on the mass. So, we'd have to imagine being someplace without gravity to be able to get a good feel for what mass is. But we're just still going to use it. So the amount of mass per unit of volume. So let me explain that last little phrase. What that means is per unit of volume means if you have the same volume of each material. So let's go back to our bricks and feathers. If you have the same volume, maybe you fill a box, identical boxes with feathers and bricks, and then you ask which is heavier. Well, obviously then, the bricks are going to be much heavier, okay? Because they are more dense. In the same amount of volume, the bricks would have more mass, all right? What I want to show you in this video is how to calculate the density of a material. Every material has a particular density. It's a number that we can describe, and it tells you something important about that material. We can often identify a material based on its density. Okay, you could look up on the internet, what's the density of water? What's the density of brick? What's the density of certain kinds of wood? Of course, these are all slightly different depending on which type of wood you have. So let me show you how I'm going to have you calculate it. It, of course, starts with a formula. Okay, this is almost just the formula, which is the same as the definition I gave you above. So we take the mass and we divide it by the volume. Notice I'm writing the division as a fraction. Okay, when you write a fraction, you really are writing a division problem. So you take a number, you hit the divide sign on your calculator, and you take the next number, and that's how you get a measure of the density. Sometimes we write division with this little symbol over here. And you could do that as well, mass, and then that, and then density. But on modern calculators, we're going to use like a little slash anyway, okay? All right, so when I have you do math problems in here, just like your math teacher does, they want you to show the formula with words and letters first, okay? I am okay if you write this. That's just a short version of what I've written up here, okay? You must write that for every problem, every time you're asked to calculate a density, okay? All right, so let's do a sample of a density problem just so you know how I expect you to have them look. Okay, so I looked up some data on the internet and I found a problem we can do. So we'll do it this way. The mass of a brick is 4,000 grams. I'm using kind of just an average brick. its volume is 2,000 cubic centimeters. Remember, cubic units when we measure volume. What is its density? So that's how I would pose the problem. Okay? 3 steps. Always 3 steps. The first step is to write the symbolic equation, which is what you're looking at the top of the screen here. Okay? So you would write D equals M over, that's a capital V, by the way. I know it's hard to tell the difference. And then, now if I had more space on my paper, I might move downward, but I'm okay with you moving straight across. You rewrite it again. This time, though, you substitute in the values given in the problem. So whichever numbers you're given, you replace the appropriate letters with those. So if you're given the mass of 4,000 grams, it needs to go where mass was in the equation. So that's up here. And then the volume is given, and so you put in that number and its unit in place of V. Again, I know you typically do this for your math teachers as well. And then you grab your calculator if you need it, although in this case, I hope you don't. 4,000 divided by 2,000 is 2. And always write the units that go along with your final answer. So this would be grams over cubic centimeters. We say grams per cubic centimeter. Just to make sense of that answer, what this means is if we were to take a small little cube, 1 centimeter by 1 centimeter by 1 centimeter, that's a tiny little thing. Then a brick, if we took a brick and made it that size, it would be about 2 grams of mass, okay? That's what we mean by density. All right, that's not so bad, right? Let's look at one more example just to see how we could twist it up a little bit. All right, so let's look at this next example here. Suppose we have the 3 dimensions of a textbook as well as the mass, and we want to know what its density is. So notice this time we don't have the volume directly, but we do have the information to find the volume since a book is a rectangular solid. And we learned early on in this unit how to find the volume from those 3 dimensions. So this becomes now a 2-step process. Okay, so step 1, we would need to calculate the volume. And remember, you always write the symbolic equation first. Okay. I'll let you abbreviate volume with capital V if you wish. Substitute in the numbers. These are actually somewhat realistic numbers. I measured some books I had around here. And then you need to grab a calculator or use Desmos or Google or something like that, probably to do that math. Although this one you could do by hand as well. I did it and got 3,750. And then remember your units. Centimeters by centimeters by centimeters gives you cubic centimeters. But that's just step 1. Now that we have the volume, we do the density calculation. The mass divided by the volume. I have a little more space this time, so I'm going to write it out vertically. That's kind of my preference. So make sure you're putting the right numbers in the right place, okay? Remember, mass is measured in grams. It has a mass of 24,000 grams. Always use commas on these big numbers. And then what's V? Well, V is what you just calculated from the dimensions. Always show that you're substituting in the numbers. I don't want to guess where everything is coming from. I will make you rewrite it if I don't see it. I guarantee you that. Okay? And here again, we have to punch this into a calculator. Please don't try to do these by hand. It just ends up being a big mess. I get 6.4 grams per cubic centimeter. Okay? 6.4 grams per cubic centimeter. So kind of a compound problem there, we might call it. 2 steps. in order to get to the final answer. Okay? I sometimes like when you're doing a multi-step problem to put a box around your final answer. And please keep it kind of organized. Don't have things all over the place. It just ends up being messy and difficult to follow. I will make you rewrite it if you do it that way. So do it right the first time, and I think you'll be happier. Okay? All right, so there's a couple examples of calculating density, and you'll get a chance to practice this a little bit on your own. Hope that was helpful for you. If you need to go back, rewrite anything in your notes, you can always go back because it's a video. You go back, replay it, write it carefully, listen again if that's necessary.